So hey, hello everyone, and I welcome you all to Rankplus JEE English. In this video, I'm going to showcase you my very special talent, which is to concise the hardest topic in a simplest way. So in this video, I'm going to concise the chapter Moving Charges and Magnetism within 30 minutes. And after watching the complete video, your all the concepts and all the formulas will be revised, and you will be able to solve the JEE previous year questions within few seconds. I can bet that. So let me start this session without wasting time. The PDF of this session you can get on in our Telegram group. So do not forget to join our Telegram group. The link is in the description. So do check that link. And other than that, to watch my detailed lectures, you have to subscribe the YouTube channel. So this chapter is basically talking about two different things. The first one is the force and the second one is the field. So let me start first thing with the force. And the force here could be on two different things. If I'm telling you that we have to calculate or to find the force, I am basically more concerned about the magnetic force. I'm more concerned about the magnetic force, right? So it could act on a single charge. When a single charge is placed in a magnetic field and it is also moving with some velocity. So for a single charge, I am having a magnetic field as Q V cross B. So the question might come in a vector format where the velocity vector will be given to you, or either you will be having a magnetic field vector. Okay, then you have to do the cross multiplication. So this is one of the method. Other than that, if you open this, you will be getting QVB sine theta, right? So this is also one of the formula which we are having. But I can extend this formula if I have the magnetic field plus the electric field. So write down one note here. In case of electric plus magnetic field, there is a special force which we have to calculate. That force is known as Lorentz force. That Lorentz force is basically a sum of electric and magnetic forces acting on the charged particle. So the electric field is QE and this is Q V cross B. Okay, so this will be my net force on a charged particle. This is known as Lorentz force. This is known as Lorentz force. The other pattern for this was for the single charge. The other pattern for this, if my charges are not single, it will be mingle, right? So it is in the format of current. For a current carrying conductor, the force acting on it when it's placed in a magnetic field, you can get the magnetic field as BIL sine theta. So these are the forces. These are only two formulas which you have to keep in your mind. Very simple, right? This is the concise power. Now, another, if you have to find the torque, the second part is if you have to find the torque, then torque is equals to BINA sine theta. Bina sine theta. It's also a very important formula. And once we are done with the forces and the torque, now it's time to go for, like here, I am finding that we have to get the magnetic field, right? Here also we are having to find the magnetic field. Here also we are having the magnetic field. Here also we are having the magnetic field. So how we are going to find the magnetic field? Yes, Elan's tube, super punch. No, it's not a one shot. It's basically a very small video to make you revise this complete lecture. So in this video, I'm going to basically showcasing my power to concise any topic in a simplest manner so that you can learn the formulas, you can revise the chapter within few minutes. I'll be not taking more than 30 minutes. Okay. So this is for the force. Like if you have to calculate the force which is the magnetic force, you will be getting only two types of questions. Either the charge will be a single charge and it is moving with a particular velocity. If there is no charge, the magnetic force will be zero. So on neutron, we won't be experiencing any magnetic force, right? Because the charge is zero in neutron. Similarly, if there is no velocity for a static charge, we will not experience the magnetic force. The charge particle must be moving, right? Now, let's move towards the magnetic field. Towards the magnetic field. Now, to find the magnetic field, we have two laws. Let me first write down the laws which we will be using. So, one law is Biot-Savart law. It says that if there is a current carrying conductor, I'm making a table here, and assume that if there is a current carrying conductor, and due to this current carrying conductor, I am considering only a small portion out of this. I'm considering only a small portion out of this, and due to this small portion, this current carrying conductor is carrying a current I at a distance r, which is at an angle of theta at this point P. If I need to find out that what is the magnetic field, basically I'm calculating the magnetic field due to a very small part, so the magnetic field will also be very small, right? If the part is small, the magnetic field will also be small. So at this P point, my magnetic field will be equals to dB. dB shows that the magnetic field is very small, and that will be equals to mu naught divided by 4 pi I dl sine theta divided by r square. So this is the magnetic field which we have to calculate. Okay, I think that it's done. It basically depending upon the angle, it depends upon the small distance which we are taking, it depends upon the current, and it also depends upon the distance. And the second law is Ampere's circuital law. Second law is Ampere's circuital law. In this Ampere circuital law, we says that mu naught I enclosed, mu naught I enclosed, B dot dl. B dot dl is equals to mu naught I enclosed. Okay, now in the later chapter, you will study that this I enclosed will be equals to mu naught times the conduction current plus the displacement current. So this is the ultimate Ampere circuital law which you have to remember. Okay, now the important patterns on which the questions might come, important pattern or the magnetic field you must know is due to a straight wire, due to a straight wire, and due to a loop, due to a circular loop, you must know. I'll show you. Okay, I hope that this thing is clear. The first one was about the force, magnetic force. The second one is about the torque. Torque is equals to B now. The third one is about the magnetic field. So for calculating the magnetic field, we have only two laws, Biot-Savart law and the Ampere circuital law. And using these laws, we have to find out the magnetic field in various conditions. And usually we will be finding that we have to calculate the magnetic field in the straight wire or circular loop and the combination of these things. So let me show you that which type of pattern might come in your exam. Very important patterns. This is important for JEE Main as well as JEE Advanced. So the first pattern is if there is a straight wire and at a distance r from a particular point, I'm standing here at P point. If you see here, and you are making an angle theta 1, theta 2. So the magnetic field at this point will be equals to mu naught I divided by 4 pi r sine theta 1 plus sine theta 2. Okay, the current is flowing in this direction. This this magnetic field basically tells us about the magnitude only. The direction, for the direction we have to use the right hand thumb rule. Okay, so this is the magnitude which we are calculating. For direction, we have to use right hand thumb rule. Okay, now let me now for a straight wire I'm talking about. So this is a straight wire. Let me copy this thing. If I'm having a finite wire, this is a finite wire. And now I'm saying that, let me delete this. This is basically a finite wire. Now, if there is a infinite wire, so for an infinite wire, the condition is that this angle will be 90 degree. Assume that you are standing in front of the Burj Khalifa. You are looking like this. The angle which you make is 90 degree. So if I'm having an infinite wire, so at a distance r, at this point I'm having a magnetic field as mu naught I divided by 2 pi r. That you must know. And for the, let me again move to the third part. Is this thing clear? First, do tell me, is this thing clear for a finite wire, for an infinite wire? Miru ella annaru. Vivek Lingala. Theta is 90 degree, correct. Theta is 90 degree. Okay, for an infinite wire, theta is 90 degree. So this is important pattern, and let's move towards the third. Third is that you are standing at one of the end. You are standing at one of the end, and at one side, this wire is infinite. So if you want to get the magnetic field value here, what you need to do is mu naught I divided by 4 pi r. Now one sine is 90 degree and another sine is 0 degree here, right? So sine 0 degree is 0, sine 90 degree is 1. So I'll be getting, my answer would be mu naught I divided by 4 pi r. Now there is a very simple question which I am going to ask you. Okay, very simple question I'm going to ask you. Assume that there is a current carrying conductor. Okay, the current which is flowing through it is 20 ampere. The length of the wire is 10 meter, and I am standing at this point which is at 1 meter from this wire. Now you tell me that how much magnetic field is there due to this wire. Tell me. 0. Magnetic field here due to this wire is 0. Why? Because if you see that this point is at 0 degree with this wire, isn't it? I hope that this thing is clear. Now let's go to the another part. Another part is we were covering very important pattern. We are covering very important pattern. And the next pattern which we have to do is a circular pattern. Assume that there is a circular loop of radius r at a distance x from this. At this point P, you have to calculate the magnetic field. You have to calculate the magnetic field. At what is the value of the magnetic field? This, there we are having a current going II. At this point, if you need to get the value of magnetic field, the magnetic field will be equals to mu naught I r square divided by 2 r square plus x square power 3 by 2. Remember this formula. This formula is very, very important. Sometimes student faces issue while remembering this formula, but this formula is very, very important, right? You have to remember this formula. Now assume that if you are standing at this point and I tell you that you are at a distance x from the center O, and I'm telling you that if you move towards the center, what is happening? Your x is decreasing, right? And what if you reached at this point? So B at center, you have to put x is equals to 0, right? So for getting the value at the center of this wire, of this loop, you have to put the value of x as 0. And if you put the value of x as 0, you will be getting the magnetic field at center will be equals to mu naught I divided by 2r. So this is what you are getting. Okay. And this is now let's see. What if I'm having a circle here? If this is a circle, there is a current I, the radius is r, and if somebody is asking me that what is the magnetic field at this O point, so the magnetic field at this O point will be equals to mu naught I divided by 2r, right? Very simple. Now if I'm telling you that you are having a semicircle, if you are having a semicircle, can I draw a semicircle? Yes. I hope that it looks like a semicircle, right? Yes. Please forgive me if this doesn't look like a semicircle, because I have done drawing and painting till my 3rd class. After that, student used to tease me that these are the act of a girl. Girls do this painting and drawing everything. So I left that drawing and painting from my 3rd class, and after that I become a rowdy boy, right? So now if current I is flowing through it, the radius is r, you have to calculate the magnetic field at this O point. Now tell me, I always tell you that you do not have to see the picture. You do not have to see the picture, you have to see the pixel. And what is pixel here? Pixel is that whenever you are getting a question, you have to divide that questions into multiple parts. So I have divided this question into multiple parts. So I'm telling you that the magnetic field at this O point will be due to three parts. The first part is the left part, and this O point is directly in front of this wire. So due to this wire, the magnetic field at this point is 0. Similarly, the magnetic field due to this right hand side wire will be 0, because the angle is 0 degree or 180 degree. But due to this semicircle, what I am having is, for a full circle, I'm getting the magnetic field as mu naught I divided by 2r. So for a semicircle, the magnetic field value will be mu naught I divided by 4r. So this is the value which I'll get here. Similarly, you will be having a quarter, you'll be getting a quarter, or a very, like there could be a unique pattern in this. But remember this thing, if you remember only these formulas, because the important task is to learn very few things and have the ability to apply those few things in any difficult situation is the art. You know what? How to get success? How to get success in IIT? For getting a successful life, you need a science which is same for everyone, same for you, same for me, same for everyone who is preparing. But there is also an art which is different for everyone. Which is different for everyone. Science is same for everyone, but art is different for everyone, isn't it? So to get a very good rank, I would be saying that you have to master both of these things, the science and the art. And you know that I'm an artist. I'm an artist to concise every difficult question of physics in a very simplest manner. And if you follow my notes, you'll see that using very simple things or using very minimum formulas, you can able to solve hardest question in your exam. And that too within few seconds. It won't take much time. But I can bet on that. Is it clear? Semicircle? Yes. No, Sumanti, you can watch this for your CBSE exams as well, but this is for the JEE. In JEE also, you will be getting this thing. In CBSE also, you will be getting the same thing. The beauty of all these things is that it do not get changed. I'm from Delhi. Where are you from? Vivek? Telugu? Telugu? Okay. Hyderabad. I can understand Telugu. Like Miru Ellannaru, Ichi Noru Musko. There are so many things. Is it clear? Shall we move? Shall we move? Shall I give you a question? Even you will see that even in your JEE Advanced, you will find the questions from these topics only. These are very, very important. Jayant, yes, basically I'm trying to do every topic. Okay. I'm trying to be more regular. It's like give me 5 to 10 days. After that, I'll be taking a very long sessions, and also previous year series is also coming. But these important sessions in which I'm going to concise very like I'll not be taking more than 20-25 minutes of yours, but I'll going to concise each and every topic, which will be very useful to revise the formulas, which will be very useful if you want to score and revise all the things, right? So I'm winding up this session here only. Other than that, you have the galvanometer. Galvanometer is a very important topic. You must know that how to change one galvanometer, like how to change the galvanometer into ammeter. The other important factor is you must know that conversion of galvanometer is very important. In this chapter, we are also having a conversion of galvanometer. So galvanometer is basically a device, very sensitive device. If I'm taking that if Ig current is flowing through it and the Rg is the resistance of the galvanometer, the voltage of the galvanometer is IgRg. Okay, now if I need to change this galvanometer into an ammeter, what I can do? Galvanometer to ammeter. I have to connect a shunt wire with it. I have to connect a shunt wire with it. This is a shunt wire, and if I current is flowing through it, you can say that the voltage on this side will be equal to the voltage on this side. So I can say that Ig, if Ig current is flowing through this side, the I minus Ig current will flow through this side. So Ig Rg will be equals to I minus Ig S. So this is a very, very important equation which you have to keep in your mind. Okay, there could be a different formula that if I need to get the Ig, if I need to get the value of the shunt, I can easily calculate using this formula, but this formula is very important. So we basically connect a shunt. Shunt is basically a very small resistance connected in parallel to the circuit is known as shunt. Other than that, you must be knowing that how we are going to convert the galvanometer, to voltmeter. So to convert the galvanometer into a voltmeter, we have to connect a very high resistance in series. So if I'll connect a very high resistance in series, the voltage across it will get increased, because the voltage here will now be Ig Rg plus R. Okay, so now the complete chapters, every topic is completed. So please download this PDF from the Telegram group. The link is in the description, and share this video with your friends if you get any benefit from this video. Okay, so I want notes of second year chapter, sir. Vivek, okay, just ping me on Telegram. I'll share. Sir, is it possible to do this in? Yes, Ved, you can do that. There is a separate video for. Okay, now I'm ending this session here. Bye bye. Best of luck. Bye. Do hit the like button and comment that which chapter you want me to take the next session. Okay, because this is a special series, which is, I think that there will be a huge benefit of attending this series, in which I am covering the complete chapter within 30 minutes. The important formulas and the important patterns I am covering. So in this video also, I showed you the pattern of questions you might be getting in your real exams. So I'm concising it again, that in this chapter, basically you have to deal with the forces. Forces could be in a single charge or in a current carrying conductor. Then you have two laws, Biot-Savart law and Ampere-Circuital law. And using these two laws, you have to find out the magnetic field in various conditions. So these two conditions would be either in a straight wire or in a loop. So in a straight wire, this is the formula. For a loop, this is the formula. And you will be getting that you have to combine these formulas to get your answers. Okay, I'll be live again on Tuesday. I have my schedule session on Tuesday. In that session, I'll be taking atoms and nuclei. Okay, and I'll also be sharing the highlighted NCRT for that chapter. So thank you everyone for joining this video live, and do share this session with your friends. We'll meet again in our next sessions. Bye bye. And please do watch my shorts videos, because in that I'm sharing very simple tips to ace the JEE exam.